Hi everyone, this is Dr. N.G. Praveena, working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. In this video lecture, I am going to discuss about the types of the data transfer instruction that we use in 8086. What are the topics to be learnt by this discussion? The types of the data transfer instruction. We have the types of the data transfer instructions such as move, exchange, push, pop, in, out, load, effective address, load, storage, flag register. So we'll discuss these instructions one by one. So the first instruction what we are going to discuss is about MOV. It transfers the byte or a word. The mnemonic is MOV. The meaning for this mnemonic is move. How the format has been done, move d comma s. So the operation has been undergone like this. The content of the source has been given to the destination, while under this operation the flags will be unaffected. Whether it is a status flag or a control flag, all the flags will be unaffected. As all of us know, we have 9 flags altogether. Example, move AL comma BL, move AL comma 5000, move SS comma DX. In these instructions, the content of the source will be moved to the destination. The content of BL will be moved to an AL. The content of this memory location 5000 will be moved to AL, whereas the content of DX will be moved to an SS. This table tells you that what are the possible moves you can do, whereas this tells you that what are the things you cannot move. Here you cannot apply this move operation between a memory to memory and from immediate data to a segment register and between a segment register to a segment register. And this table, under this table I have listed all the possible moves. The second instruction what we are going to discuss is about EXCHG, exchange byte or word. The mnemonic is XCHG, meaning is exchange, format is exchange XCHG D comma S. Operation is nothing but the content of the source and destination will be replaced with each other. The flags are unaffected under this operation. So example is XCHG AL comma BL, XCHG AL comma 5000. It is nothing but the content of BL and AL will be replaced with each other. Similarly, the content of this memory location 5000 and content of AL will be replaced. Here this table tells you that what are the possible exchange can be done. Exchanges can be done between an accumulator and a 16-bit register, between a memory and a register, and between a register and a register, and between a register and a memory. You cannot apply this instruction between a memory and between a segment register. The next instruction what we are going to discuss is about push and pop. The mnemonic is push. The meaning is it will push the content from the stack. Format is push yes. S is nothing but a source. Operation is the content of the source will be moved to the stack of memory. Here flags are unaffected. And pop is nothing but pop, you are getting the output, you are getting a data from the stack of memory. The format is pop D, whereas D stands for destination. Here the content of the stack will be applied to a destination register. Here the flags are unaffected. Here an example is push AX. Assume the content of AX is AB and FF. When this instruction is executed, push AX, the content of AX will be pushed to a stack of the memory, the two on the top of the memory. So AB followed by the lower LB, lower byte followed by the higher byte. When you go for the second example, pop AX, when you execute this instruction pop AX, the content of the memory will be given to a AX register. So the top of the memory location is AB, it is given to a AL register, and the next memory location you have a data FF, it is given to a AH register. The next instruction what we are going to discuss is about in and out. These instructions are meant for giving the input and getting the input to the ports. Mnemonic is in, meaning is you are giving an input. Format is in D comma port. You are giving the input from the port to the destination. Here flags are unaffected, and the second instruction is out, meaning is output. How the format is here, out port comma yes. So the content of the source is given to a port register. Here the flags are unaffected. Example, in AL comma 0F8H. The 0F8 is nothing but a port number, okay, which we use in a processor. So in AL0F8H, when this instruction is executed, the content available in this port number 0F8 is moved to a AL register. When you go for the second example, out 0F8H comma AL, when we execute this instruction, the content of the port, the content of your AL register will be moved to this port. The port number has been given as 0F8. The next type of instructions what we are going to discuss is about load effective address. Under this you are going to study three types of instructions. One is LEA, LDS, LES. We'll go one by one. What is LEA? Load effective address. So this load effective address will load the effective address from to the 16-bit register. So the format is LEA register 16 comma EA. So effective address is moved to a 16-bit register. Here the flags are unaffected. And the second instruction is LDS, load register and DS. The format is LDS register 16 comma memory. Here the memory data location has been given to a register 16 and the memory will be given to a DS register. And here also the flags are unaffected. And the third instruction what we are going to discuss is LES, load register and extra segment. It is nothing but LES register 16 comma memory. Here memory will be given as register 16 and the memory will be given to a data will be given to a data segment register. Here also the flags are unaffected. For each and every instructions I have given you some examples, basic examples to understand the instructions. The next type of instruction what we are going to discuss is load store flag register. Under that we are going to discuss four types: LAHF, SAHF, pushf, popf. We'll discuss one by one. LAHF meant for load AH register from the lower byte of the flag. As you know that the flag is a 16-bit register, so when we execute this instruction LAHF, it loads the content, it loads the lower byte of the flag register into AH register. AH is nothing but an 8-bit register. So LAHF, this is the format of this instruction. When this instruction has been executed, the lower byte of the flag register data is given to a AH register, is copied to a AH register. Here also the flags are unaffected. And the second thing instruction what you are going to discuss is SAHF. It is nothing but store the content of the AH register to the lower byte of the flag register. It is not an upper byte, it is the lower byte of the flag register. So SAHF, this is the format of this instruction. Here the content of the AH register is given to a flag register, that to a lower byte, least 8 bits. Here also the flags are unaffected. And the next instruction what we are discussing is push F. When we say push F, it is nothing but pushing the content of the flag register to the stack. As you know that the flag register is a 16-bit register, so the upper 8-bit and the lower 8-bit has been taken and it is moved to the stack of memory. Assume the format of the instruction is pushf. When this instruction is executed, the upper byte of the flag register is initially moved to the stack, followed by the lower byte of the flag register. And the last one what we are going to discuss is pop-f. Pop flags from the stack. You are going to take the flags, okay, from the stack. So when I say the format is pop-f, when this instruction is executed, the content of the stack register is moved to the upper byte of the flag register followed by the lower byte of the flag register. Hope this video is helpful for you to understand the types of the data transfer instruction that we use in 8086. Thank you all.